Hey, I'm in. Good. Robert, can you hear me? Any Robert?
You're
Yeah,
coming in clear.
yeah, loud and clear. How am I?
Thank you.
You're good.
Okay, thanks.
You sound good.
Hey, is it Antarctic Robert in here?
Yeah, yeah. Hello.
Hey, sorry about that. I forgot your last name. What's your last name?
Short man.
Too many Roberts, man. Hey, I got a question for you.
Yep.
When you were in Antarctica, you were down there, you said, for 18 months?
Yep.
Did, did you observe the sun staying above the horizon for any period of time?
Summertime it was more, but it didn't. Wasn't overhead like they said it was, and it
Was
was.
it
Okay,
24 hours?
but listen,
No.
stand by. Let me let everybody know
Oh.
what happened. Okay? We were trying out some new including software which allowed us to lock the room, and encountered some technical issues. So we're back to this broken ass Google Hangout. Once we figure out what the technical issues were on our side, all the future Hangouts will be conducted using a program called Jitsi. Jitsi.org. Highly encrypted, secure, low latency. If I start experiencing some bandwidth problems regarding my mic, forgive me, I'll mute, probably come, for a little bit, let it correct itself, but that'll be it. So, today, what are we going to talk about? Could the Earth's atmospheric layers act as a telescopic lens? We're not going to talk about that first. Whoever's got the watch page on, mute it right now.
Yeah, I think it's Anthony.
Yeah. Mute it. You can hear everything that's being said, and then you can watch the chat section, answer any questions for people if you want to participate in the chat. But I'm going to let John take it away in the beginning here. He's got some things to show you guys, and then we're going to have a conversation about that. There's going to be a lot of things we're going to talk about. Again, I'm going to say it one more time. Mute your watch page, because I can hear an echo.
Anthony, are you there?
I'm
Tony.
here, but I don't even have a watch page open.
Okay, so it's either you, John, because it's not me.
No, I don't have a watch page open.
Well, somebody's giving some serious feedback and echo. And let's just see what happens. John, go ahead.
Let me share my screen 1 second. Are we good to go?
We're good to
I
go.
hear you loud and clear.
Go ahead and start.
Okay. The other day, after our presentation, someone sent me this, and this was one of the official Navy documents, and it had this picture in here. And I just wanted to have everyone take a look at this for a few minutes and see if you can spot any logical inconsistencies. So that's everyone out there in the chat. I hope this is
No,
big enough.
you got to make that bigger, man. Blow it up.
Okay, 1 second. I just wanted to have everyone. Is that better? Everyone see that okay?
Yeah, we're good. Everybody's good.
Okay.
Go to the watch page. Go for it.
Okay, so it says above sensible atmosphere up here, and up here, right over here, whatever that means. It minimizes susceptibility to GPS jamming and simplifies deconfliction. Okay? And as you can see here, it has the naval railgun firing from the ship 200 plus nautical miles this way. Right? To hit a target, it explodes over here. So it goes up 500,000 feet. Right? That's 95 miles. And then comes down and hits a target, right? And it explodes. So I just wanted to put this up to see if anyone can spot any logical inconsistencies here, and then we'll go over in about a minute or so.
Wait. So this was something that somebody has sent you regarding the Navy railgun?
Yes.
So they're saying the Navy railgun has to point up at that trajectory to fire to hit its target, to fire that round.
And it's GPS guided 95 miles up. It shoots 95 miles up. That's 500,000 feet as an indirect fire weapon, right? If you look down here, it says no propellants, no explosive warheads. I'm giving the game away here a little bit, but and look at the drawing.
What is this graphic show?
Yeah. That's
about the railgun.
That entire. If no one else is gonna say it, fuck it, I'm gonna say it. That entire illustration is ass backwards.
Yeah, it is.
Ass backwards. Someone put, I don't know, maybe this was some sort of pre-concept that they thought how the Navy railgun was going to work. But when you look at that straight linear line where it says indirect fire, that's a bunch of bullshit.
Yep.
Yeah.
Can you point out the logical?
There's no way you can fire that bullet from the Navy railgun at Mach 7 and then it's going to drop, it's going to lose Mach 2?
Yeah, right.
It hits its target?
Right. That's one.
And then GPS guided? It's just a fucking piece of metal.
That's what I was.
That's what, nothing in it. No guidance.
Okay, let's explain it. It says GPS guided, right? But there, look down here in the left-hand corner. There's no propellants.
Yeah.
So how is GPS going to guide this thing if it has no propellants?
Exactly.
Okay.
Yeah, because they look on Google Earth and then they figure out where the target is and then aim it at the target. That's GPS guided.
All right. What's another thing that stands out to you? Is there anything that stands out here?
Everything's flat.
Everything is flat.
Exactly.
See this?
And here's the interesting thing. You see where it says time critical? Why would time need to fucking play a factor? I guess they wanted to coincide for the GPS guided concept, huh?
This is preposterous right here.
This is absolutely preposterous. And on top of that, the round being fired out is totally fucking disproportionate. It's bigger than the goddamn ship.
yeah, that's true. But this is the one I wanted to focus on. This was the biggest one, the GPS guided, when it has no propellants. That cracked me up.
Jay, who sent this?
It's part of a Navy document. Hold on one second. Let's go down here.
And you know what's interesting about this, or how this completely contradicts what they show in the videos? When they fire the railgun, it sure as hell is not pointed up in a 30, 45 degree angle. It's pointing exactly level with the ground.
Yeah.
I think it was attached to this document right here.
Okay.
Now look what this says. 1 second, please.
Blow it up, dude.
Yeah, it is blown up.
Yeah, Ben Farrell says, don't arrows work like that? When you shoot an arrow up in the sky, they're going back to the ancient Roman shooting your arrow days.
Yeah, you have to also do that.
Railgun.
Cannonballs as well. Cannonballs have to go up and down to get the range. So that's obviously what they're thinking, but it's rubbish.
I'm trying to find. Here it is right here. It's inside this Navy document, right? So hold on one second.
I can't believe that somebody wanted to try to debunk this by sending you that illustration.
Man, nothing goes 95
Illustration
miles
itself.
high.
See, look at over here. It says propellant charge. None.
Nothing can even reach 95 miles high.
Okay, listen to this. Look at this one. This high velocity may also mean that attacking reverse slope targets with the railgun projectile will be more difficult than conventional weapons, right? If they put this diagram to scale, this is a reverse slope target.
A reverse slope target.
Yeah,
Oh,
yeah.
man.
Reverse slope. Let me show you what that mean. What I mean by that, Robert. Hold on one second.
They're showing a flat map, and they draw a linear line saying that's indirect fire, meaning you can't see it. Meaning you can't see it.
Let me show you what. Let me show you that again, Robert. I'll show you what reverse slope here is.
200 miles.
Remember when I said the bulge height?
Yeah.
This is the reverse slope. So anything on this side is reverse slope. That's what they mean by reverse slope targets. So they just hammered the C4 fire right in their own face, is what I'm trying to say. So,
Oh my God.
so there you go. That's all I wanted to point out. I mean, there's other logical inconsistencies here we don't have to go over because that one just blows it out of the water. This GPS guided part was cracking me up. With no propellants. They must be doing it by telekinesis.
Yeah, so basically they can guide this 4,500 mile an hour projectile using GPS, and it has no electronics inside of it at all to guide it.
Right, exactly.
Now I want everyone to look at the common sense of that in chat. I want someone to answer for me how you can literally GPS guide a munition that has no electronics inside of it.
It has no propellant. It can't adjust.
No propellant, and it's flying at 4,500 miles an hour at Mach 7.
And how much speed is it going to lose getting up here?
And nothing's gonna bring it down. First of all, it can't even go. If you shoot it at that angle, it's gonna try to reach 100, 200 miles and up, and then you can't go that high.
Yeah, okay.
Yeah, look at this. Now it says it goes at Mach 7.5 up to here, and then Mach 5 to hit the target. That's friggin' baloney.
Yeah, question everything made a joke. He says, no, of course they have propellants. They're called small nanobots.
That's about it, I think.
Oh, dude, I can't believe somebody tried to debunk this dude. Pay attention.
That's an official, dude. This is an official Navy document.
Oh man. No, when was this put out? Was that put out after the railgun got tested or before?
1 second, let me see if I can find that.
Because if it was put out before, that means that they were still in concept, and this is what somebody's concept drawing was. Because the data I saw after, the illustration they show, the Navy railgun is literally level with the Earth.
It's page history. It was last updated 1 August. That's all I know.
Of this year?
It says last updated 1 August right down at the bottom down here.
Oh shit.
So I don't know when it was put out, but
Now,
it's
is that
hilarious.
a Navy website, or is that someone else's website who put that up?
No, it's this guy, whatever this, Navy Weeps or Weeps. Yeah, they're weeping.
Look at the website design. That's not an official Navy website. That was something somebody else put together, man.
Oh, okay, okay.
Yeah, that's not an official Navy website.
Okay, that's all I got, Robert. I'll stop
Yeah.
screen sharing. I just wanted to show it.
Yeah, that's not an official Navy government website, but I'm not going to play semantics and challenge it because of that fact. It's just the illustration itself is self-explanatory.
Yeah, it's just stupid.
Yeah.
It's so many logical inconsistencies. It's a laugher.
Yeah. And then if anyone wants to claim that this electromagnetic pulse fired out of this gun is acting as you can guide electricity using GPS, then you definitely lost your mind. So you definitely lost your mind.
Eric said the gun angle is GPS guided.
Yeah, the
Gun
gun.
angle is GPS.
That's what somebody said. Eric says the gun angle is GPS guided. Oh, dude, that's hilarious. That is hilarious.
Oh,
Hey, Robert, did you want to present anything? Robert.
Yep.
Is he still there?
Yep. Hello.
Did you want to present anything?
I'm just looking now. I'm just thinking about the actual railgun. I mean, it sounds like absolute nonsense. I mean,
Yeah, it just I had someone else try to explain that's how it's firing off.
there's no way it does any parabolic arc. It fires in a straight line.
Exactly.
Yeah.
And at that speed, it wouldn't need to do any arc like that. If it was going up like that, it would travel more than 200 miles going at that speed.
Yeah, it's absurd.
I'm actually looking at the official naval research scientific.
and then what they're saying is that they're insinuating that they can adjust the power of the shot in order to get the different ranges. Because angleless by itself won't get the exact range that you need for a knot. You're gonna have to adjust the power of the shot. You know what I'm saying?
I'm going to watch the official YouTube page on the U.S. Naval Research on their railgun and see what they come up with.
I got a video I want to show everybody, so everyone can see what this gun actually being fired. Let me do share screen right now. Hang on here for a second. What the hell just happened? Let me do this. I want to show this video. Hang on here for a second. So here you go. Look at this.
An electromagnetic bolt. The projectile comes out of the barrel in a fireball of molten metal, traveling at 7 times the speed of sound, as fast as going from Washington, D.C. to Philadelphia in 3 minutes. The projectile sheds its steel cladding and destroys whatever it smashes into. In this case, a dummy warhead from an incoming missile.
7 times the speed of sound. But by the way, we could probably carry hundreds and hundreds and hundreds of these on our ships, just because they're so small. They're so small.
Does this mean that gunpowder is a thing of the past?
It may mean exactly that, David.
According to Rear Admiral Matthew Clucker, Chief of Naval Research, the railgun is also dirt cheap compared to the multi-million-dollar cost.
Mute your mic on the other side.
That projectile costs about 1/100th of the cost of one
Is
of our
that
traditional
Anthony needs to mute mic?
This costs right here about $25,000.
There's an electronic guidance system inside so it can be fired at moving targets.
This gun and the projectile round take care of any threat that flies in the sky. It could be a ballistic missile, it could be a cruise missile, it could be a threatening aircraft.
Traveling at Mach 7, it can also pierce 3 walls of reinforced concrete.
This is a lab gun. And it shoots a slug about this big. So think about that, a slug that big. A slug that big going Mach 7 puts a hole through 6 half-inch steel plates this big. Just this little slug went through all 6 of those.
The railgun is scheduled to go to sea for the first time in 2016 aboard this cargo ship for further testing. It's still just a potential weapon, but one that could break the seemingly endless cycle of each new generation being more expensive than the last. For CBS This Morning, David Martin at the Naval Research Laboratory.
I mean, promising, but also incredibly scary.
Yeah, I missed the science behind it, but very impressive.
Yeah, the Navy ain't
And
playing.
scary.
The Navy ain't playing. It's good to know that we have it. I just hope we never have to use
Yeah,
it.
Rear Admiral seemed proud of it.
Yes, he really did.
Unbelievable.
Wow.
Washington, D.C.
At no point did I see it angling up 45 degrees, and even the shell was just a pure solid shell. It wasn't one that had like aerodynamic falls to adjust it in trajectory or anything like that. It was just a solid piece of thing with fins at the back like a rocket.
Right, and I believe they already used it.
Yeah, they just
First
test
time
it
I
as
it
far
was
as a straight
presented.
line. It's like a bullet. It's no different.
First time I saw it, I couldn't help but see the resemblance of the impact at the Pentagon.
Ah, oh shit. Here we go. Here we go. You hear that, John?
Yeah. Well, I mean, it did leave a nice clean hole, didn't it? It didn't leave a 747 hole or anything like that. There
Yeah.
was no engines
No
on it.
wings or fuselages or any semblance of any type of plane. But they claim they saw fighter jets going overhead, but no, that's not. The video does not show any fighter jets at all.
I think it's
So
one or two
everyone
things.
realized that it was some type of projectile.
It's a
Meant
railgun or
miss-
it's a cruise missile or something like that.
that's what everyone thought it was. Shot 2 miles out from a plane or something. But I mean, it came directly parallel to the ground and hit the building.
Yeah.
Yeah.
I mean,
It was at
that
so
round
low
is.
altitude.
I mean, think about it. They're firing that round from a great distance, and it's going through 6 plates of sheet metal, and it looked like, to me, those 6 pieces of sheet metal, does that look like a round that has to go vertical 500,000 fucking feet and then come back down to put a hole through 6 pieces of sheet metal that are 11?
Well, you saw
I mean,
saw
does
the
that make
angle.
sense to you?
The
Does that
angle was
really make
90
sense?
degrees. Yeah, 90 degrees it was angling at. It was coming through the thing. It weren't coming at it 180 from the top, was it?
No,
They weren't.
those
They didn't
those
have
pieces of
plates
sheet
laying
metal.
horizontal, waiting for it to come down on the target. No, they had
Exactly.
sideways.
That's my fucking point.
If they're firing it from a ship to a ship, then they're not going to be wanting to go through the top of the hull. They want to be going through the side of it to do the maximum damage and rip through the whole.
Exactly. Exactly. I mean, when you see that demonstration, and he says that the projectile.
You don't see a ship missile coming from the top. It always comes in from the side every single time.
So I dare anybody, please try to debunk the railgun again on a globe. Please try to debunk it again. Please show us another cartoon.
We need more challenging, challenges.
We need more cowbell.
You know what I mean?
Unbelievable, dude. So the next thing I want to talk about is this. I'm going to do the share screen again because the title of this show is Could Earth's Atmospheric Layers Act as a Telescopic Lenses? Okay? I don't know how many different layers we have. I do know that lasers at 22 watts firing up into the atmosphere are hitting a sodium layer at 90 to 110 kilometers. Okay? That's what we do know. Okay? That's what we do know. That they're hitting something between 90 and 110 kilometers. So what I'm going to do now is I'm going to pull up that virtual bending light experiment that I showed you guys earlier on in the week. And for those who didn't see that video, you can always go back to it. And what we're going to do is this. We're going to experiment. We're going to conduct some online experiments, okay? Some online experiments here. So if everybody can just let me know if this is, everybody can see this. Let's do this. Can everyone see this on the watch page? Yeah, they can. Okay, great. So here's my laser beam. All right, let's say that this is the 4 laser guided facility in Chile, right? Here's our laser beam. Here we're on the ground. We're 90 degrees, right? So what's the angle I want to put this bad boy at? Let's say that laser beam is firing a beam up into the sky around 40 degrees, okay? Here we go. So now, here's the experiment we're going to conduct. We got 650 nanometers. John, what at 22 watts, what does that convert to? Hello? Anybody? Hello?
I'm going to have a look.
Hello?
Repeat
Dude,
the question.
I got a ghost panel.
We gotta mute and we gotta watch your what you call it at the same time. Three.
Okay. So someone let me know what 22 watts converts to at 600 converts to in nanometers. 22 watts. Let me see if I can find it pretty quick myself. Okay. Watts convert to nanometers. Gotta love Google, dude. Newton meter. Let me see here. So
It's
from
0 point. Hold on. My fault. Hold on a second. 0.00611 nanometers. 0.0061 nanometers.
yeah, I don't think it's gonna let me convert it all the way down there to that. I don't think it's gonna let me. It's not gonna go to 0.6. No, it goes as low as. So let's just say we'll stay on this spectrum. We'll stay at 650 nanometers, and we don't know what the power wattage of this laser is. So that kind of makes the experiment, you know, quasi okay, but there's nothing I can do about it. So let's do this. Let's go with a curved. Would we say that's convex? Okay. Let's say this is the atmosphere, right? This is the first layer of atmosphere. Let's say that that's the first layer of atmosphere, right? Let's say that there's a second layer, right? Let's say there's a second layer. Hang on a second. Well, I should be able to move this bad boy around. What's going on here? Okay. Here goes your second layer, right?
Okay, hold on a second, because the calculator is saying, can you see my screen?
No, I can't see your screen. You have to talk to me about it.
Okay, it says I got a watt to Newton meter per second, right? That's not what you want. You want
No,
nanometers.
we got to go with spectrums of light. So that's where. Don't worry about it. Don't worry about it. I want to do this. Get this set up right so it's angled right. That's what I want to do. Okay. So we got a second layer. Let's add a fourth layer. I'm sorry, third layer. Okay. Let's add this. Bring this down a little bit. Okay. I'm going to move all of this back just a tad so that we have some sort of perspective here. Right? I'm going to move all of this back so that we have some sort of perspective.
Yep.
Level this off. Remember, we're firing it from flat Earth, right? Flat plane. It's got to go right in the center. God damn it. That's still level, so I'm probably moving that over. So let's just say I wanted to add this top layer. So I'm going to move a lot of this shit down this way. So here we go. These are our layers of atmosphere. You got your first layer, second layer, third. So you have the troposphere, right? You have the mesosphere. No, I'm saying troposphere, stratosphere, mesosphere, thermosphere. Okay? Your thermosphere, let's just say it's flat up there, right? And then everything that globers are claiming to see, everything they're claiming to see at high altitude, they say they see a curve. All right, I'm not going to disagree with that, but here's the thing. If I want my environment, let's say it's water. We'll experiment with air first, okay? So we'll do air. Our objects, what do we want to say? We want to say that those are air as well, right? Okay. But we have to say that our environment, let's say that those are going through water. Because we've got some condensation up there, right? We got some liquid up there. So I'm going to do the waves, right? And here we go, people. This is what could be potentially happening from the surface of the Earth as we look up into the sky. Boom. Now, does anyone remember a term being used where they talked about atmospheric scattering? Does anyone remember that?
Yes.
Okay. So, looking at this, we've got our oh shit, wait a minute. The top environment changed. My bad. I don't want that happening. I want it to be water. Okay? So let me fire that again. Let me fire that laser again. Okay. Still the same thing. We got air below. We have the environment being water. And look what you have in every single layer. You have what's called atmospheric scattering. But you look how much reflection you have back on the Earth.
Mm-hmm.
I'm hoping everybody in chat sees this. Look at how much reflection you're looking back on the Earth.
It's a huge amount, isn't it? Not much.
Yeah.
That's a huge amount of reflection. So when you look at your stars at, say, the first level, right, the stratosphere is about, what? When you're flying up in the stratosphere, you're looking at somewhere between, what, 30,000 to 70,000 feet, right? Around 60,
within that
30,
range, yeah, that's the
yeah,
flyable
around that
yeah.
range. Then beyond that, you're looking at your mesosphere, right? Your mesosphere is here. Look how much scattering you have.
It's the next
All right?
layer.
So they're hitting. Look at this. You see how you have this lateral scattering? That's that barrier they're hitting at ESO, European Southern Observatory. But then after that, you don't have as much direct concentration of anything going out beyond the thermosphere. It looks like everything stops right here, right in this barrier. You have your high concentration here, but you have, look at all this atmospheric scattering you have. All right? I'm not saying this is what's happening when we look down the surface of the Earth and what is happening with a laser beam. I don't know what the wattage of this bad boy is, but again, we're screwing around with this and we put this in several different layers. Okay? But if I change the environment above to air, okay, which we know it's not. We know it's just not plain air up there. That means that that laser beam shot from Chile should have gone straight through. Way. It should have just kept on going. Robert Shortman and I had a conversation yesterday with someone who works for a really big company who's been supplying optical and video, advanced technical video equipment to NASA and just about every other space agency on this Earth. And when we described to this guy, we asked him, what do you think would happen if a 22-watt laser was fired up into the nighttime sky? Would it stop? He goes, no, the laser would just keep going. And when we told him, what if we told you that the European Southern Observatory fired a laser, 22-watt laser up into the sky, and it hit something at 90 kilometers? He says, well, I'd be pretty shocked on why that happened. And we told him what was discovered. We sent him to the website, and he was baffled. He couldn't explain it. And this is someone who's been working for this company. What, Robert, did he say, like 9 years or something like that, right?
It's incredible, yeah. He worked for that, and he also worked for another company, kind of rival company as well. So he worked for two satellite companies, so he knew what he was going on about, and he was kind of shocked as well. As Robert was kind of describing it.
So when we look at the top environment being air, okay, air, that laser at the European Southern Observatory should not be stopping. I mean, we have a little bit of atmospheric scattering here when you see these black marks, but the laser should keep going.
Absolutely.
You got air below, you got air above. Now,
That's
if
what
I
he said.
change, go ahead.
He said the same thing. He said, yeah, they just go on for infinity and beyond, and that's what he said. He said
That's what he
they
said.
shouldn't reach any layer or anything. He didn't even mention a layer. He just thought that and
Yeah,
presumed
because
like,
the layers get less dense as you go higher.
Exactly.
yep.
That's what he said. Now get this. If I change the objects to water, okay, look what happens.
Oh,
Look what happens.
Wow. Oh my God.
Look what happens, people.
That's incredible.
When I change the objects, now these objects means, let me explain this. The objects that I put up in here, these concave and curved lenses, right? These are supposed to be acting as prisms. Our upper atmosphere, there are layers: troposphere, stratosphere, mesosphere, thermosphere, but Soho's calling it the heliosphere. And then you're supposed to have what they don't even use the term exosphere anymore. You know why? Because they don't even know what's beyond the exosphere. We know that the temperatures are pretty hot up there, but we don't know exactly how hot they are. You know, Soho couldn't explain how the temperature goes from tens of millions of degrees from the sun, and then a million miles away from the Earth, they cool down to 5,800 degrees Kelvin. And then when you get down to the troposphere, you're looking at somewhere around 130 degrees in the summertime. That didn't make any sense to me, but we're going to try to answer that question next week with John and I when we talk to the Soho team again. But when you look at this, there is water above us. How much water is above us, we don't know. We just don't know. But if you want to assume or presume and go with this right now, what I'm telling you, each atmosphere has its condensation layer. You got some layers that are more dense than others where ice is just forming and coming out of the sky. You got hail. You know, you got blocks of ice coming out of the sky. But when you shoot a laser up into the nighttime sky, these 1, 2, 3, 4 different layers, look what happens. You got light being scattered every fucking where.
that's a pretty good representation of what we're seeing.
Look
Can
at
the
the-
environment
Yeah,
can the environment go in between air and water and just sit there?
Well, that's what I'm saying. We
I'm
don't
talking about
know.
on this model here.
Wait, say that again?
Can the environment sit between air and water
I don't know.
on this
We're
model?
looking at this virtual experiment online.
I'm saying on this virtual experiment, this tool on this tool can the little cursor sit between air and water? Can it?
You mean put this between?
The environment. Put the environment with the top right in between air and water and see if it stays.
Put this between.
In the top right, in the gray box where it says environment,
Oh, okay, hang on.
move it to in between air and water and see if it can stay there.
That would be custom.
Okay, yeah.
So if we do a custom environment, which we don't know what it could be. Now, let me explain this now because I use this for my physics classes. When you go custom, that means you don't know what is there. You're just experimenting to see what happens.
Mm-hmm.
And then the goal is to figure out what could that custom environment be. All right?
Okay, so I want the environment to be like that, right? And we're just going to assume that some of the things
What about your objects? You want to keep your objects at water or air?
I want the top object to be glass.
Yeah, same here. That's how I was thinking.
So you want... No, I can't change this.
I want to move
They all have to be the same.
the lenses. I want to move the lenses out of the way in between the laser and the top object, and then make it glass, and then shoot your laser.
So you want this top one to be glass?
Yeah.
Yeah,
So
I can't.
since all of them change the glass, you got to move the lenses in between out of the way for just for a second.
Oh, so you want me to move all of these?
Yeah.
Okay. So let me move these out of the way. And he wants the top to be glass.
No, not the environment.
Not this environment. Okay. You're wanting the object to be glass.
Yeah.
Okay, so here we go. Look what happens. Look what happens. If the top object is glass, let me center this.
You get a focal point back down, don't you? Pinpoint almost.
You still get reflection
Yep.
back down to the earth if the top is glass.
So if it's glass or water, it does the same thing.
So if the top is glass, you're almost getting identical reflection, and you're getting a little bit of refraction. But it's not coming back to the earth. It's going out somewhere else. That's what you're getting. But think about this. That's not what's happening. Because even if you have glass up top, you still have these other layers.
Yeah, you have the lenses in between.
You still have these lenses. You have the atmospheric lenses. Okay? You have the atmospheric lenses. All right? You got your troposphere, your stratosphere, your mesosphere, and then in here you got your glass dome. All right? Supposedly, these objects are water. You got to factor in, because you figure you got your clouds, right? Keeping your barrel on a pressure. You got humidity. Yeah, you have your humidity. You have all of that to factor in.
And just the moisture in the atmosphere, definitely.
Yeah, you go. Robert said it perfect. Moisture in the atmosphere, and boom, here we go. I changed this in the middle. We don't know what the environment may be. We know our objects. Water. Okay, and here we go. Boom. Same atmospheric scattering, and that's what not even knowing what's in the environment. Look at this. Look at all of this refraction. Look at this.
We may be able to assume that the atmosphere can be measured properly. You know what I'm saying? When they say it's like how much nitrogen? 70% nitrogen or something?
Yeah, that's the thing. This application doesn't allow you to factor in those type of variables.
Yeah, that's why you got that custom right there.
So that's why you only have the customs. You know, you got to know. Here's the thing. You would have to know. The reason why you do custom and mystery A and B is because here's the thing. You can be able to screw with this light. All right, I can reduce this. Let me change this here for a second. Okay. Let's keep going. Look what happens even when you change the frequency of the light. It's the same effect. It doesn't matter. Even when you go ultraviolet, look what you got. You still have the same refraction of light.
Yep.
You still have the same. I mean, even when you increase the intensity and you go to infrared, nearly 700 nanometers, you still have the same refraction. Now, let me throw in another variable, because remember I talked about nanodiamonds, right? I talked about nanodiamonds. NASA claims space is filled with nanodiamonds. Right? And I made a statement that there's a possibility They could be what we think to be stars, right? Stars. All right? So here's what I'm going to do. Here's my troposphere, okay? I'm going to throw in my diamond. Okay? Say this is a diamond. So I'm going to configure this way. No, I don't want to put it in the, no. It's got to be above the stratosphere. My bad.
Right.
My bad. It's got to be above the stratosphere. So there's my stratosphere. Say my nano diamonds are at this. This is where my nano diamonds are.
Hey, Robert.
Yes, sir.
Hey, sorry for interrupting, but could you tell Anthony to mute his mic? We're getting a lot of feedback.
Anthony, he's watching another damn show, isn't he?
No,
No,
Anthony has his Anthony has his mic muted on the watch page and the volume turned down. Not
Hey,
me.
it might be you, dude, if the TV's on.
I can see Anthony feeding back there. That's the
Is
only
it
thing.
you, Devon?
Oh, is it me?
Yeah, it's you, dude.
Oh yeah, that's better.
Okay, so here we go. We got troposphere, stratosphere, nanodiamonds, right? And maybe sodium atoms, where the European Southern Observatory are firing. Let me go back to 650 nanometers here for the laser. Okay, we got the mesosphere, we got the heliosphere, right? Our glass dome. All right. So we don't know what the environment is, but here we go. This would be your nanodiamond. Actually, you know what? Fuck. Here we go. Ooh! What the hell? Look at all the atmospheric scattering.
Wow. Wow, that's incredible.
So anyone want to know why astronauts keep saying they don't see any stars in the sky? Here you go. Here's the reason why. When you get above the mesosphere, you don't see anything because all that light is being refracted and reflected back on the Earth. Nothing can be seen at eye level at this altitude. Nothing. That's why they can't see anything. That's why so if they can't see anything at this altitude, what makes you think a telescope on the fucking ground, an observatory, can see anything light years away? I'm asking everybody. What makes you think we can see out beyond this distance and the universe is supposed to be just fucking flooded with all these stars and nebulas and supernovas and planets they claim are millions, tens of millions of miles from the Earth? Think about that. Because everything, when they fire those lasers up, and even when they got to look into the nighttime sky, what are they getting? I'll show you what they're getting. And let's do this. I'm wondering if I can create two of these bad boys. Hang on. No, can't do it. Let me see something here. I'm going to switch this laser. Let's say this is the sun. Let's say this is the sun. Okay? Let's come down.
Flip it round, yeah.
Yeah. Let's say this is the sun.
Yeah, you're on the right path. Yes, sir.
Let's say this is the sun.
Raise the sun up.
Okay? Here's your nanodiamonds. Right? All right, let's flip this bad boy around. Woo! Here we go. Sun. Okay? We all ready? Here we go. And the sun's supposed to be fucking brighter than 650 nanometers. Oh yeah. Let's take this bad boy. Let's max it out. The sun's supposed to be putting more than 700 nanometers of light down on the Earth, right?
Right. If nanometers are the same as, is that the same as Newton meter per second?
No. It's different. It's different.
Okay.
Boom. Whoa! What the hell? So anybody want to tell me how far the sun is again? And the sun is in deep fucking space, and it's supposed to be doing this down on our Earth? I don't think so. The sun is actually closer. And I'm going to show you how fucking close it is, too. I'm going to show you how close it is. Oh, shit. Hang on, let me, I'm a little discombobulated here. Damn it. Let me take that out. So, if we look at it this way, right? And I got to bring this down the scale here. Got to bring it really down the scale. Bring it down. If this is supposed to be the heliosphere, right? I'm gonna say that the sun has to be inside here. Now, does that look right? No. Because it's supposed to be going through water, right? It's supposed to be going through water. So if we go through water and we make the object, no, I'm sorry, not the environment. The environment is air. Okay? And the objects, let's just say we're going through some air too. Because that's what they're claiming. That still don't look right. Okay, I'm going to say something irresponsible. I don't know what the fucking sun is. I don't think it's a sun. I think that everything that we've seen up in the sky is fucking being created, is literally being created from the angle that we originally showed. That's what I'm, and there goes my artificial environment, my simulated universe theory right there. That's what I'm saying. I don't mean to put it out there like that, but it's starting to make me wonder now. And of course, this laser beam is nothing close to mimicking the sun. But I'm sorry to tell you here, right here, that the sun could be some sort of artificial projection making us believe it. That's what it is. Because think about this. If you fired a laser beam in the daytime, would you really see it? Nope.
Nope.
You're not going to see a laser beam, a powerful laser beam being fired up into the daytime sky, creating what you believe to be the sun. Because get this. If this was an artificial, if this was a laser beam, a powerful laser beam being shot in the daytime, right, through air on the ground, okay, through air on the ground, and you have all of this atmospheric scattering, then these beams that are getting out are being projected onto a sun that's right here, somewhere in here, to create a visual image you see in the sky. But the question remains is, where's all this atmospheric scattering? Could they just be heated up atoms emitting their radiation and excess energy back down onto the Earth? Here you go, right here. Look at all of the refraction coming back. So you have all of these atoms up in the atmosphere being heated up by a laser, a powerful laser, and at the heat you feel in the daytime from what you believe to be the sun, what you believe to be the sun is actually radiated energy from large collection, massive areas of atoms in the atmosphere in different layers, and then an image out from a distance is giving you the illusion that we've got a fucking sun 350,000 times the size of the Earth. It's giving us off light. That was the craziest thing I ever said. But when I look at this, that's what I'm thinking. That's what I'm thinking. Anybody want me to manipulate this another way?
I'm just thinking. I think you've done a pretty good job so far. It's really kind of cleared up how it looks from inside and outside.
That has to be it, man. That absolutely has to be it. It has to be it.
I mean, if they're getting the
I want John, I want you to show that link you just put up in the chat to show everybody those different visual images of how the light, they claim the light is actually refracting and reflecting back down on the universe. I mean, back down on our planet, I'm sorry.
Say that one more time, Robert.
You put that link, that was Robert Shortman. Robert Shortman, why don't you show that link? I'll do the share screen for you and present you. Show that link that you just put up in the chat, the group chat.
Will do.
So that everyone can see exactly what they are telling us, how the sun is actually reflecting and reflecting light back down onto the earth. I'm presenting you, Robert, so go for it. You there, Robert? 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 Oh, dude, we lost him.
Fell out.
I guess I'll show it till he comes back. Let me show this to everyone. I don't know what happened to him. So this was something that Robert Shortman put up in the group chat to show everyone. I'm going to illustrate it right now. I just clicked the wrong fucking goddamn thing too. Son of a bitch. Okay, so here we go. Here's some images that Robert Shortman gave. And look what you got here. You got the sun going through its cycle, right? Varies with latitude, and this is what they claim how it's supposed to be behaving with a. Oh shit!
Sorry, yeah, I got kicked out, but you can show it anyway because it's quite clear the angles. I mean,
yeah,
you can see the angles how it intersects from that, and you can see how it intersects outwards from the diagram you gave.
Yeah. So when you look at this from what the sun's doing based on this angle, they're claiming on a sky dome, this is what's supposed to be happening. Now here's the interesting thing about this image. this little drawing of this house is on a flat plane level. And then you have, the sun somehow hitting the sky dome, but light somehow they're claiming light is getting through. Not according to the map, not according to the illustration we just showed, but I'm not saying that illustration is 100% correct. But when you look at this one here from physics.weber.edu, you're claiming this is what's happening, what the sun is doing down on the earth. This is just absolutely inaccurate. Look at this. It's not happening this way. You've got tons of atmospheric scattering. You've got tons of atmospheric scattering. The sun is not giving us the light. Our sun is not giving us off any light. I mean, look at this image.
It's a fixed point, isn't it? It's coming through.
Yeah, it's coming from which means that if you find something up into the sky from the surface of the Earth,
you'd have vertical beams going straight down. You wouldn't have it coming in at that angle, spreading out.
No, not through the clouds. if you heat up the atmosphere and you're heating up these sodium atoms, like ESO says, and they get bright enough, this is your daytime. This is what happens when the clouds are over and they're shooting down like this. And eventually that glow goes away when you're not heating up that layer anymore.
You just get a hot spot.
That's it. You just get nothing but a single hot spot that they claim is coming from 93 million miles away from the Earth. That's what they're saying. It's impossible. It's impossible. And then how do you explain this being underwater as well? How you just see this collection of light coming through the water. It's the same thing. Now, I know John's going to chime in and say, okay, how are you going to prove this? I know that's what he's going to come in and say. So I'm going to let John take it away and give his input and assessment on this using scientific method.
Well, there's so many. Yeah, listen. There's so much misunderstanding with refraction, transmission. There's so many variables that it's impossible to get through them all. I mean,
yeah, you're absolutely right, man.
Especially when you're talking about the entire Earth, whatever that is, and the sun, whatever that is, and what it's going through, and whatever that is. I mean, you got so many unknown variables and confounding variables that you can't. I don't think you can get to it. I don't think you can get to the answer. That's my opinion.
Yeah, and again, I mean, I'm with John on this. I mean, we briefly touched base on this. I mean, we've been doing videos going over every possible variable we could discuss and break down. But when we have to put this all together, I mean, we're talking about 1,000-page research paper. 1,000 pages. We have to throw in nanodiamonds, sodium atoms, gas compositions, exact altitudes, exact angles, exact power outputs, temperatures. We got to factor in all of this. And what we go through on a daily basis, just living our daily lives, is so highly dynamic where you could watch the news right now and the weatherman says, well, there's a 95% chance of rain at 6 o'clock tonight. You go out at 6 o'clock tonight, you're like, well, guess it's not going to rain. There was a 5% chance of it wasn't going to rain. But you took your umbrella. It's just we can't get a static, fixed frame of reference on any amount of data to make a definitive hypothesis with verifiable and confirmed dependent variables and independent variables to say, okay, shit, we had to rush and we only had a 20-minute window to do this experiment, but we don't know what happens after that. Because as soon as we present the paper, everyone who's going to read it says, well, your entire paper is null and void because during a 1 hour time frame, these other things occurred. We just can't, we can't establish exactly how, when, where, and why it's happening. We can only go with what's already available out there. And the information and data that's out there right now, based on that online software virtual experiment we just conducted using a laser beam and assuming that the atmospheric layers are water or air, what we did confirm was that the data that is out there regarding what they discussed with regard to atmospheric scattering and atmospheric turbulence, we just saw it for ourselves. We saw it in a virtual experiment for ourselves. And we saw how there's no fucking light coming into the Earth from 93 million miles away. It's not happening. Not if we have 4 to 5 layers of atmosphere with varying pressures and varying gas compositions and varying components and molecules. It's not happening. Every layer, those light beams or particles, like John wants to say, I call them. I shot a laser wave, not a particle wave. But if we want to, regardless.
Photons are particles.
Okay, photons are particles. When you
Listen,
fire,
so
go ahead.
imagine how NASA and the boys felt when they first saw these things way back in the 50s or whatever, 50s and 60s, and they first realized this. I mean, they just must have threw their hands up and said it's over, and then that's when they created the whole industry, the whole
No,
imaginary
this industry
everything.
of optical illusions has existed, I think, since the dawning of humankind. I'm now more convinced that there's some other far more advanced group of whatever put us here and just basically decided, okay, we're going to let them go through these time frames and slowly reveal these capabilities to them so they can maintain their own environment. I mean, I have people emailing me, telling me, and confirming and giving me the data, telling me that pyramids were not designed to bury people. They were designed for some sort of atmospheric type of anomaly where they were collecting in photon particles or waves or whatever from the sky and regenerating some sort of image up into the air.
Really? Were they communicating with dead pharaohs to know their intent?
No one knows, but what they do know is that when they take these thermographic images of the pyramids actually doing something when they shouldn't be doing anything at all.
I know that they did use perfect measurements to create these things, and actually
Yep.
creating these perfect measurements created a certain harmonic frequency within the structure itself, and the measurements are most important because that's what creates the actual frequency effect. It's not the actual frequency that's created, it's the measurements within that do it.
Right, the geometry itself draws water at
Yes.
its base.
It does,
So
yeah.
and
And those
used to
are
have a
always
moat around
linked into the groundwater system. So it's interesting.
I thought though all those people were dumb goat herders.
That's what they make us to believe, yeah.
Oh, John.
Yep, and they had mechanical tools too. You know what I'm saying? Automated tools as well. It's the only way you can get particular grooves in ancient buildings, ancient building blocks. They see these perfectly smooth grooves in some of these buildings, like Puma Punku.
Yeah, when you've got thousands of tons of rock and they just shape it without any effort whatsoever, and they're perfect.
That's not lining up with the narrative. These people were stupid, remember.
Yeah, but that's you see, how do we know
They use
that
bones to smooth them up.
Bones and wooden tools, yeah.
The narrative is that these people were stupid and there's no way they could have done this. Okay, if they were stupid and they couldn't have done this, that means that someone of a higher level of intelligence with the advanced technological capability came down, because we've seen all these hieroglyphs and these paintings inside these pyramids of them always looking and pointing up into the sky. That some people came out of nowhere and says, hey, you guys are a bunch of fucking idiots. We got to teach you some things.
Right, because we're their little pets, and they got to train us.
Yeah, and these aliens, they evolved from pond scum on Vega, right?
No. We're not going on the God narrative on that one. What I'm saying is that I don't give a shit who created them. Is it possible? We don't have. I said this in my last video on perspective. We do not possess the technological capability to view anything 48 million miles away, or even 258,000 miles away, which NASA claims that's where the moon is. We don't. Because if you can stand on the surface of the Earth with your own naked eye and you've got perfect vision or you're wearing glasses, On a clear night, you can make out some of the features on the surface of the moon with your own eyes.
You only need your eyes to see it.
That's what I'm saying. So
The
you
reverse of that, you'd see the bloody Earth. It would be massive. It would be absolutely massive. And you'd be
exactly.
looking. You'd be looking. I can see the Great Wall of China going past.
And they're trying to tell us that they had a bunch of guys stand on the surface of the moon and it looked really small.
Mhm.
But it's 200. That's what 258,000 miles is supposed to look like. I'm sorry, that's not what 258,000 miles.
And the only thing they can see as far as the activity of the stars are supernovas. They never seen a star being born. So the supernova is clearly just a local event that they're lying and saying happened 17 million years ago, and the light finally reached us.
Dude, it could have been something happening on a fucking computer screen at CERN. Because that's what they're doing. That's what they're experimenting with, using light at high speeds. I think, well, I can, no, let me retract. I'm not thinking anymore. I'm just going to go out there and say, based on that experiment we just conducted, accurate or not, based on real data or not, you saw it for yourselves. The only way to project that image we see in the sky right now, what we believe, what we've been told to believe to be the sun, giving us light and heat, making everything on this earth that is in the ground grow vertically, has to be something generated from the surface of the earth, heating up the atmosphere and the atoms in the atmosphere so that they glow for however many days of daylight we say that we have. They're making the upper atmosphere glow, give it its color, and then keep it charged, and then you have nightfall, and you start over again on the other side of the plane to give those people their experience of daylight. Could this have existed for thousands of years? Absolutely, if it was a far advanced, more advanced species than we are at this very moment, and we have been. Because we don't possess, we can't create the advanced technological capability to see fucking Mars or even get there. We can't. Someone used a pair of 12 by 80 binoculars to see the surface craters of the moon that they claim is 258,000 miles. No, everything is either tens or thousands of miles away from us.
Well, I don't know, Robert. I pulled out my binoculars. I stood on my roof.
And what could you see?
I saw 10 days earlier. I peered through the binoculars, and I was looking 258,000 miles away, so my line of sight wrapped around the Earth 10 times.
There you go. There you go.
I saw myself walking out the house 10 days earlier, taking out the trash.
You dilated time with binoculars?
That's what he's saying. That's what they're claiming that we're supposed to be able to do is get a pair of 12 by 80 binoculars, and we can see back 10 days. But you know what? That dawned on me, because my uncle, every time I did something wrong, he said, "Boy, you better get your ass over here. I'll knock you in the middle of next week." I'm like, "Damn, let's get it over with, then, because I got an exam to take."
I wouldn't say that.
Now I know what he was trying to tell me. That we're capable of time travel. Forward and backwards.
My aunt used to say, I'm only trying to kill you because I love you.
They use the Mars as an excuse for extending their potential schedule, so they can say, "Oh, we'll do that in 20 years," and that means they've got 20 years of trillions of dollars. That's the only reason they do it, because they haven't got nothing on the moon. They haven't got no webcams or stations or bases or anything like that on the moon to prove anything. So they just go off to the next one because they know they can't go onto the moon, they can't go onto Mars. So they have to keep kind of pushing out the envelope and making an excuse for that. It's a great way of doing it.
You know, when I think about this, right, and based on what Devad just said, if the moon, let's just say we become NASA buffs, you know, we love them so much that we want to agree with them. if the moon is 258,000 miles away, technically speaking, when you think about time, that means we're looking at a moon that doesn't exist. So from a metaphysical and psychological standpoint, because we imagine, we've been told the moon is there, we're collectively projecting the image up into the sky. It's really not there. Because if they say that light can be seconds old, minutes old, you know, months old, it's not years old, then is the moon really there when we see it? I know ESO shot a laser at it, so
Is
something
that
was
a
there.
question?
Go ahead.
The answer is yes. The moon is there. It's just not where they say it is.
No, it's not yet. It definitely is not there where they say it is. It's definitely not. I mean, the next time any of these space agencies say they want to be able to launch something to the moon and crash it on there, I want them to fucking televise it. I want to see it for myself. Make sure you do it on a night where there's a new moon, too, where the whole world can see that fucking thing just go poof, like the coyote when he fucking launches his rocket, you know.
You'd be able to see the dust cloud kind of thing.
You see the dust cloud just come up. I mean, I want a big fucking explosion, too. Just launch a damn nuke.
That's not a problem. The day they do that, I'll buy an expensive telescope and I'll zoom in and watch them land because I'd love to see the day and the
Oh
day
yeah,
that
I'd
ever
love to see
come.
that as well. I'd love to see that as
I'd
well.
film it. I'd get it live, everything, because they're not going to do that. They're never going to get anything up to that
No,
point.
no, they're not. They're not. So, anyone got any questions? Anyone got any comments? Anybody have anything they want to share? Anyone?
I want one of these guys that's spending all these money on these rockets and balloons to launch something into the sun.
Oh, they can't do it. It burns up before it gets there.
Good. And have the feed pointing upward at it.
And now I'm of the belief that every balloon that they showed they've launched, where it just pops, because they said it obtained its maximum pressure and expansion and it just burst. I'm now of the belief that it hit that layer of the thermosphere and just heat just caused it to pop, not the actual altitude.
Yep. They're gonna pop at the same.
Yeah, if they're popping at the same altitude, that means it's hitting a heat barrier and it just pops. It's not because of pressure. Because if that were the case, you tell me how it is that I've seen data of balloons getting launched to they claim to 1,000 miles, which is not possible.
Wow.
Let me see the data. I want to see the telemetry data for that balloon that got to that altitude. Period. So, you guys saw that virtual experiment. Anybody want to play around with it themselves and put together a little video? What I will do right now is I will put the link in chat for everyone so that you can go to the website that I use for my courses I take online with Columbia University and Johns Hopkins. They've got a whole bunch of experiments, virtual experiments you can conduct, and play around with it. Put together a nice little video. You know, maybe go through the tutorial. And
yeah, that sounds fun.
That's the way to do it, really.
See what you can do. Here's the link for everyone. I'm putting it in the chat for everyone who's listening. You can go there, play around with that bad boy, and that's it. Lee Harvey Hitler says, Robert debated Red's rhetoric. He won't debate me, man. He was supposed to debate my boy John, and at the last minute he backed out. The last minute. The debate was supposed to take place on his channel, and at the last minute he backed out.
Hey, hold on, Robert. Hold on, Robert. That might happen.
It might happen. Okay.
Yeah, it might happen. I'll get back with you on that.
Okay. So John will be debating Red's rhetoric. Robert, when will you call companies next week? I got a phone call. Actually, Robert Shortman and I got a phone call being returned by a big company who provides the cameras and optical technology for NASA. The guy actually took down my phone number. He says, "Yeah, I need to research some data for you." We had a 29-minute conversation. It was Robert. Tell him what do you think of the conversation?
It's the most incredible conversation I've heard. It's more than eye-opening. I mean, you know, the actual chap was quite intrigued with what Robert actually had to say, and as soon as he started pointing out interesting things, you know, the chap was like, I'm not quite sure about that, and I'll have to look into that. And half the stuff, well, most of the stuff Robert said, he couldn't understand why they weren't doing it and why this wasn't in place. And you'll have to see it. It's pretty awesome.
Yeah, so I'm not going to post that because this guy's going to follow up on a call with me, and Robert Shortman and I are going to have a few phone calls. I mean, a few questions to ask him, and because he said some things about not being able to take photos of Antarctica because of the snow. But when you go on Google Earth Pro, you can see the shoreline of Antarctica.
You can see the icebergs, and you can like zoom into the cracks and everything. So it kind of disclaims the fact that you can't see pure ice, because pure ice and an iceberg is no different.
Yep. So that was interesting. I'm gonna make next week. John and I are gonna have a phone call with the guy from Soho that I first spoke with. We're gonna ask him a few questions. So yeah, we will be doing that call. It will be live. And I've got a few other phone calls lined up next week. I don't want to telegraph who they are and what I'm going to talk about, because there's trolls out there listening, and then you know them. They'll probably fucking be the first ones to get on the phone Monday and says, "Hey, some guy named Robert Sal's going to call you. You better be careful." You know. But I expect the calls every single week. Every week, I got somebody new. If you haven't seen the latest call I did with the girl from the media desk at NASA, asking her about the cameras and where they were, that was pretty comical. But Robert, someone just posted a suggestion to you about crowdfunding a balloon launch. Great idea. Yeah, that's it. Robert, have a moment with your creator. You are aware, not awake. Peace. Addie says that I'm I'm aware, but I'm not awake because I'm not connected with my creator. Robert, what do you think about crowdfunding a balloon project? I think it's a good idea to crowdfund a balloon project. I've already contacted someone who does balloon launches. This guy, he's got a YouTube channel actually. His channel's called, I think it's JP Aerospace. You can actually pay him somewhere around $1,000 to $5,000 to launch a balloon for you. He'll go and do everything for you. Go out in the desert, launch it up. You tell him what you want on the platform. He'll put it on there for you, but you pay for it, and he'll do it for you. This is what he does for a living. So I have reached out to this guy. I'm waiting to hear back from him right now. But I don't want him to launch the damn balloon from the U.S. I want him to launch it from somewhere else. So I need to find out if he can actually do that. I know that Robert Shortman and we talked to the guy who was going to be. We asked him if he can provide some imagery of Antarctica because they didn't have any, and he told us it would cost on average about $1,000. How many square kilometers?
It's about 12 kilometers wide by about 1,000 kilometers long.
Yeah, so we can.
And they can actually manipulate different images, so you can get like a panoramic or different positions where they will scan around a set area.
Yeah, that's what he said. So I'm definitely going to be waiting for that guy to call back, and I'm going to finish talking to him. John and I are going to be talking to the people from the Soho satellite and Discover satellite. This guy's a subject matter expert on this, working for NASA. We got his resume. We know he's got what? John, he's got like 100 papers he authored, right? He wrote.
Yes.
Yeah, this guy's got like 100 research papers on the sun. So we got some really specific technical and non-technical questions and scientific questions to ask him about the sun.
He's got a second law of thermodynamics problem, I'll tell you that much.
Yeah, okay.
That's great. And I got my man Alim Bey, who's ready to answer any questions about the energy producing capabilities of the pyramids.
Oh yeah, of the pyramids. Yeah, I do want to address that because I'm still looking at the pyramids as producing. They either were some sort of photon generator or photon collector.
Yeah, I'm actually doing a heavy bit of research within the next week on in relation to all this.
Yeah, yeah.
Yeah, yeah.
So I know I'll be talking with Robert Shortman too. He and I gonna do a hangout on the 11th, Thursday.
That's correct. Yep.
Yeah, and then Devon's got things that they talk about. I've shared his channel already, and John and I, we try to rip a new one, and anybody wanting to talk about whatever it is they want to talk about, basically. And then I got my boy Anthony Russo on here. Anthony Russo has been in a lot of chats, being the hammer. But I'm going to tell you something about Russo. All of you guys out there that know him, Mr. ADR, this guy has got some really good analysis that is the simplest explanations you could ever hear. He's open to listening to anybody and everybody, but again, it all comes down to the same thing that comes down with John. Prove it. Prove it.
Now, we want the scientific evidence.
You're right. But then, if you have the scientific evidence, you got to prove how'd you come about that evidence.
We want the hypothesis, and we want the test. You have to test it.
Yep.
Period.
Exactly.
Stop.
We did a little test with that little laser I showed you guys. I'm of the belief the sun ain't generating anything. And that's consistent with Eric Dollard said. Anyone wants to know what Eric Dollard said, you can find him online. But he and I actually had a 1-hour conversation about the sun. And, a lot of people thought he was crazy what he was saying. I'm now more leaning towards that what he is believing, how the sun performs and where it came from and what it's supposed to be doing. He says it's acting like some sort of transformer. It's not giving off any light. It's not producing anything. It's not burning anything. He didn't know what it was, but he says it can't be what they say it is.
Did he say it was a transistor, Robert?
No, he said it was some sort of transformer.
Because I got something interesting. 1 second.
He said it was acting like some sort of electrical transformer. And if that's true, if that's possible, based on what he has put together, because he said he studied the sun for 4 years, what I just showed in that laser experiment, with all of that atmospheric scattering and turbulence at different atmospheric levels, there ain't no fucking light coming from the sun down to the earth. There is something being generated on this earth to produce the light we see in the daytime and the stars we see at the nighttime. It's coming from the surface of the earth. It's not coming from outer space. Period. Anyone wants to disprove that, then let me know when you launch on the next rocket heading towards the fucking sun, and you can take a picture of it. Because that's the only way you're going to be able to prove it to me.
Hold on a second, Robert. Here, let me share my screen. Check this one out.
Okay, hang on a second. Hold on, Jay.
All right.
Go ahead, you're being presented.
All right, check this. This is the voltage. Yeah, this is the voltage profile of the sun. Check it out.
Hang on.
Okay.
Yeah, it's showing now. Go ahead.
Yeah, the voltage profile of the sun. You can see the sun's interior photosphere, that's the surface, through the chromosphere to the lower corona to the outer corona. It's identical to a solid-state PNP transistor profile. Identical. So
wow.
I'm just saying that, and to back up what we were talking about before, remember we were talking about
you know who knows about this electrical stuff? I think that's Bob's Bob Xanadu out there in chat. I think that's him out there in chat. He's an electrical engineer. Let me shit.
Remember we were talking about this, Robert, the last time, and we couldn't get the links up. This is what I was talking about with the surface of the sun.
Yeah.
The photosphere, the chromosphere, and then the corona.
Yeah.
And there's that graph that I was talking, the temperature graph.
Yeah.
So over here's the inner core. It's 15 million Kelvin, right?
Uh-huh.
And then it comes out to the photosphere, which is the surface of the sun, right here. You see where the temperature dips? It's going down, and then, uh-oh, what's happening here? Through the chromosphere, it's heat's flowing uphill, and then it goes parabolic through the corona.
Wow.
Look at that change in temperature. From 10,000, basically 5,800, because that's right. This is about 5,800 right here in the photosphere.
Yeah.
Confirming what that Sohu guy said. But as you go, oh goodness gracious! Look at this parabolic jump. Look on the scale over here. From 5,800 to the outer corona. That's exponential magnitudes. That's 1 million Kelvin up here. Look at this.
You think that's the reality of the temperature of the sun?
Yeah. Yeah. This is a second law of thermodynamics violation from the Black Lagoon. I'm going to tell you what this is saying.
Shit. See,
what this is telling you.
You can see
what this is
right in a lab, right?
What this is telling you is there's a wooden stove over here, and as you move away from it, you spontaneously combust. The further you move away, the hotter you get.
Yeah.
So I just wanted to leave that for you. I'll stop screen sharing.
That is hilarious, dude.
Yeah.
Hopefully Bob comes in here real quick.
So when you see the recreations of the sun in a lab, right? The man can put his hand into that recreation. You know what I'm saying? He can put it in a can. He can put it in anything, and it's probably about a foot wide or whatever, and it's completely white light, and it's brighter than the sun actually. And he can just hold it on a string or whatever. You know what I'm saying? And manipulate and just swing it around all he wants. But he says that it's supposed to be 10 million degrees in that recreation. But at those temperatures, it gets cold.
That's interesting.
It's confusing.
I threw this out there to someone I talked to at NASA. I had partially recorded the call, but then they didn't really know that much, and I threw out the theory that the sun was actually a cold fusion device, meaning that instead of it emitting extreme heat, it was emitting extreme cryo temperatures.
Hey Robert, Bob wants you to send it to him on Skype.
I just did.
Okay.
Yeah, I sent it to him. It's in his Skype. Does he want me to send it to the Globebusters one? He's not logged on Skype on Globebusters. I just sent it to Bob. I just sent it to you, Bobby. You should have it. You should have it. You should have it. Yeah, and she didn't even want to talk about it. So when I asked her about black body radiation, to think about that, and I said, well, do you guys have any black body radiation detectors on Soho or Discover? She says no. I said, well, why not? She goes, well, I'm not really sure, but I can give you the link to an observatory on the ground that's measuring black body radiation of the sun. I'm like, wait a minute. How can you measure black body radiation of the sun with an observatory on the ground when you've got to go through all those atmospheric layers? You're really not getting an accurate measurement. She goes, well, they do a pretty good job. That's what she said. They do a pretty good job.
Yeah, that was about as lame as the answers get, huh?
That's what she said. They do a pretty good job, but they don't have black body radiation detectors. And for those who know a little bit about black body radiation, I'm still learning about it. Black body radiation is basically the opposite of, the extreme solar radiation. You got extreme, thermal environment, compared to an extreme cold environment. You would get, like, say, if there's something 10 million degrees Celsius, there could be something minus 10 million degrees Celsius in the opposite spectrum. So if you've got that type of extreme cold out in space, where they're claiming the vacuum of space is supposed to be extremely cold.
There is no vacuum.
No, I know that, but that's what she was saying. She was saying, she couldn't explain how the temperatures went from 10 million degrees, Kelvin, down to literally on the surface of the Earth to 110 degrees in the summertime. She couldn't explain it.
Well, did you ask her, is the sun in a box?
That's what we're going to ask that other guy, Joseph.
All right. Can't wait.
He didn't want to talk. I told her that I spoke to Joseph before. She goes, well, I think he'd be the best one. He's done more research than anyone on this topic. So that's why we're going to talk to him this upcoming week. Bob, are you in there?
I am. Can you hear me?
Yeah. Talk, John, bring up that illustration again you just showed. That electrical.
Yeah, I saw that, Robert. It looked like an avalanche zone and a tunneling diode to me. So that's actually a technical term, and I'm sure John probably understands it, but that's kind of what it looked like. That's an interesting analogy, John. I got to admit that.
Yeah, I mean, that voltage he's showing is how it just drops off. It can't be behaving the way a solar body they claim should be behaving. It's more along the lines of what Eric Dollar's been saying, that the sun is some sort of transformer.
Yeah. Yeah. Are you seeing it?
Yeah, I saw that. Yeah, that's so interesting, the way that the chromosphere, it just drops off like that. Very much, like I said, akin to a tunneling diode when it hits the avalanche zone.
Yep.
That's crazy.
So that's pretty interesting that it's the exact same. You can superimpose it. It's exactly the same.
That is amazing.
That's weird. So,
did you like the other one?
I'm going to stick to this one, man, that the sun is not giving off any light.
Hey, does he like this one?
Which one?
Yeah, that was actually the one. Yeah, that was the one that I was looking at. Very much like a Zener diode chart.
This is the temperature profile. So heat's flowing uphill according to their standard model. By exponential magnitudes. Look at the temperatures we're talking about here. This is 10,000. This is about 5,800. So this is what he was saying was the surface of the sun. That's the photosphere. See what happens here? Whammo!
Yeah.
So John was saying that means that the further you get away from the sun, you should just immediately just incinerate.
Yes, that's what this is saying. The further you move away, that's a wood stove over here. The further you move away, like 10,000 kilometers, that means it's getting hotter.
Yeah, and of course the model for a thermonuclear reaction would be the hottest at the core, and the temperature would decrease as it goes up.
Yeah,
and of course, by NASA's own figures, what happens is exactly opposite from that.
But what he's saying is, in the core right here, it's 15 million Kelvin. By the time it gets to the photosphere, it's 5,800 Kelvin. Where did the 14,999,000,000 whatever, where'd that go?
Well, yeah, and how are they measuring that too? That's another fantasy that I've often wondered. Yeah.
They're just making it up. They forgot about the second law of thermodynamics, though.
Exactly.
No, you're forgetting about magic.
Yeah, I didn't factor that in.
FM, yes.
Illusion.
GeoShifter is saying out in chat that magnets have to be playing a role in this somehow.
Oh, absolutely. I agree that the magnetic field is integral to all of this, and that's kind of why I've been on this rant for the past 6 months about magnetism, because it absolutely has everything to do with it. Oopsie. Telephone call.
Yeah.
All right, I'll stop sharing, Robert.
Okay. Yeah, this is getting interesting, people. That's all I gotta say. It's getting really interesting. That
Yeah.
laser illustration with all of that upper atmospheric scattering at every layer. We all saw it. We saw the upper atmospheric photonic scattering of light at
Yeah.
every single layer using what? A convex mirror, right? That's what the atmospheres would be. There are multiple layers. They're all spinning at their own maybe different velocities. And then you have the upper layer heliosphere. There was literally no light getting out beyond the thermosphere. That means that everything was occurring from the surface of the Earth, and that's what was exciting the sodium atoms up in the upper atmosphere, giving the appearance that you're looking at a blue sky. But here's the next experiment I think I want to do this upcoming week. What atoms could which atoms on the periodic chart could be up at higher layers to give us this blue sky appearance? And which atoms could be at even higher layers to give you a black sky appearance?
Well, I think that the black sky appearance is simply a lack of fluorescence to whatever molecular elements are fluorescing up there, and that's one of the reasons. I don't know if you heard this or not, Robert, but we're going to be doing a balloon launch here. I don't know, probably in the next month or so. But I have been kind of dragging my feet about which camera to buy, because I really wasn't sure what I wanted to accomplish, with the balloon launch. I didn't want it to be just another balloon launch. But then I got the idea, especially from one of the things that you released with the lasers hitting the sodium layer and fluorescing everything. I thought, well, wait a minute. So I have always seen as a pilot and a passenger many times where the stars seem to diminish greatly the higher up you go. So what I thought we would do on our balloon launch is to have a bunch of zero lux cameras or night vision cameras in the visible light spectrum pointing up, and we launch it from eastern Colorado where it's really, really dark, and then we can see the stars as the balloon is ascending. And my hypothesis is that once it goes probably over 40,000 feet, I have a feeling that that starlight is going to diminish entirely, which would, of course, prove then that it is a sonoluminescent type, effect that's going on up there, and that's kind of what I'm hoping to prove.
Yeah.
And as far as the atoms
if that's the case,
atmosphere,
that means stars are not
it could
millions
be
of miles.
aluminum oxide that's causing the blue.
Yeah.
Aluminum oxide, two aluminum and 3 oxygen.
Well,
aluminum oxide?
Mm-hmm.
Did you say aluminum oxide?
Right.
I wonder, isn't that part of what the chemtrails they're spraying in the chemtrails?
That's what I was just getting ready to say. The chemtrails.
It is.
Yeah.
That's what I was just. They need to do the chemtrails to keep the visual view.
Yeah, it's possible. It's interesting also is that there is some lore that kind of would support this, as crazy as it sounds. I've heard stories of the fact that when Earth went through a war previously, and the population and the surface was devastated, and now the surface has allegedly been restored, and we're being moved back up to the top layer. And it sounds nutty and everything, but it makes you wonder. It's like, are they intentionally trying to hide things that are going on above us, while we're either making this transition or not? I mean, that's total wild speculation, but some of the craziest stuff seems to come into focus when you start looking at what they're doing and trying to figure out why are they spraying this aluminum, barium, and strontium composite above us, and what exactly is the purpose? And of course, aluminum, strontium, and barium could very much have. I'm sorry.
If you heat up aluminum, barium, does it change color?
If you heat it?
Yeah. Does it change?
I don't know if it changes color so much as it provides a very stable background for holographic projection. So I'm not sure. I'm not sure it would change color, but then again, I'm not a chemist, so I don't know.
Right, because everything changes color whenever you heat.
Well, if you heat copper up, copper goes green. So you know.
Right, they're going to have different emission spectrum.
Yep.
Yeah, agreed. But what that would be exactly, I don't know.
No.
So, but it's an interesting. Why? Where were you going with that, Robert? What were you thinking?
Well, here's the thing. Whatever, if we can get a list of what they're actually spraying up into the sky, and I can take that information and put it into the virtual lab experiment and put it under different varying heat conditions to see if it changes color. Because if it changes to the color I think it is, that means that they know not only are they creating clouds to hide something they're doing at higher altitudes, but it might be assisting with the blue hue that we see from a distance.
Well,
meaning that our blue skies really are some sort of chemical reaction.
Very, very possible. Very possible.
So if I can get that list, I can start to put that data in on the virtual lab experiments to see what happens as you start to heat it up.
Yeah. You know what I'd be interested in seeing is, you know how you did the video on firing the lasers at the sodium layer? Yeah. And I assumed that the resulting quote-unquote starlight would be a fairly pure white light. But I'm just wondering if you were to fire a laser at different wavelengths. It looked like they were using a yellow laser, for example, when they were doing that. But say if you fired a laser that was outside the visible spectrum, or possibly a blue or a green one, if it would cause any difference in the fluorescence.
Yeah, you got me thinking now. I'm going to go back to their website and download the document to find out if they're actually firing, laser on a different light spectrum, because that might make a difference too. But they only say that they're firing 22 watts. So, I mean, the laser looks orange. So on that spectrum, it was maybe about between 550 to 600 nanometers. Possibly.
Yes. Yeah.
It looks like orangish red.
Yeah. Well, it kind of looked yellow to me, but whatever. Yeah. It's in that spectrum somewhere.
Yeah, that's why I wanted to go down there and see it for myself, because someone else took a picture of that. So whatever the light exposure and aperture was on that camera that took a picture of that laser, maybe give off that type of light, but the laser's light could be on a higher spectrum, or maybe right in the middle.
Right.
I'm going to see if they have the technical paper on their website to find out if they've used the lasers at a different spectrum. Because if you've seen in that video, that guy says, hey, if I put my hand in front of this laser, what will happen? He says, well, it'll get warm, but you won't burn yourself.
Yeah, and you know what? That's bullshit, because they said they were using 40-watt lasers, and I got news for you. You put your hand in front of a 40-watt laser, it's going to burn a hole right through it.
Yeah, that was that guy Domenico. Did he say they were using 40 watts?
I believe
I think it was 22 watts.
Yeah, and I mean, hell, I have a 1-watt laser that if you put your hand in front of it, it will burn your hand. It won't burn a hole through it, but it'll certainly burn it.
So 22 watts would definitely give you third-degree burns.
It would burn a hole right through your hand. In fact, it would probably burn a hole right through your body.
Yeah, and it didn't make sense, because Domenico says that they've got to call up the aviation administration to tell them that they're going to be firing it, and that it would blind every passenger on a plane, but it won't burn through your hand.
Yeah, which is nonsense. I mean, Robert, I have a 3-watt, 3,000 milliwatt, or a 3-watt blue laser, and I can literally sit in my office and I can melt solder from 10 feet away.
Oh. Holy shit.
Yeah, that is no bullshit. I mean, so when you're talking about 40 watts of columnated coherent energy, the guy, when he said that, you'll feel it, but it won't burn you. It's like I went BS with capital B and capital S.
Oh, wow. I mean,
it would burn a hole through a car.
Wow. So something now I got to go looking through the data again, because now I got something else to debunk, possibly.
Hey, Bob, what's your thoughts on that naval railgun? Did you watch that?
I've seen parts of it. I understand the way that it works. Again, you know, the projectile is what specifically are you talking about on it?
I was talking about that it's a line of sight weapon. It's like a rifle.
Oh yeah.
How can you hit a target at 125 miles away on a ball?
Exactly. Unless you can calculate that projectile's drop, which I'm sure that you could probably do that.
Well, you can't do it because there's a bulge height you got to deal with.
Right, exactly, and that's what, you know, there was some guys from the military on Mark Sargent's show that were talking about how they can paint targets well over 100 miles away, and just being able to target something defies all laws, you know, let alone firing something at it. I can see that if you lobbed a projectile, you know, and you were actually in a ball, that, you know, that would be possible. Because you could calculate the arc on it and then calculate the curvature there at the way that it falls away. And so you would basically be arcing or lobbing a projectile onto something, but it would be, you know, if it's dropping in altitude, it would certainly be losing a lot of its inertia. So I don't think it would be anywhere near as effective of a weapon as, you know, having this intense velocity, you know, kind of like the muzzle velocity right off that railgun.
Well, it's tantamount to calling an M16 or an M60 or any rifle an indirect fire weapon.
Right? Yeah, exactly.
Yeah, it's not absolute nonsense. Yeah.
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 So,
right.
Okay.
Fellas, man, thank you very much. Bob, thanks for coming in, bro, and sharing. You got a show tomorrow, right?
Yeah, we do. We have a show tomorrow, and we'll be talking about.
What are you going to be talking about?
Well, a lot of it's we're going to be talking about a lot of this silicone trees phenomenon, which I think is amazing.
That's somewhere we didn't want to go.
Well, you know, I understand it. I think
that's somewhere we didn't want to go yet.
Yeah, I think it's worth discussing. You know, whether it's accurate or not, it's certainly fascinating, and it makes you scratch your head.
Well, here's the thing. I'm still looking for any research papers because there's those areas that they show in that video. I did look at the video.
Mm-hmm.
There's a massive area in Colombia, south of me, where they turned it into a national park. It's called Chiquirique.
Yeah, they're all over the world.
When you look at these plateaus and then you look at that video again, here's the problem. You know, that data's been put out there for quite a while, but no one has actually done any kind of geological study on these, and I'm going to say so-called petrified plateaus that they think might have been trees. So if I can find the data where someone's actually drilled into one of these and did some sampling, some petrified or rock sampling, to say, wait a minute, this is consistent with what petrified trees could be, then that's when John and I are actually going to start talking about it, because it all makes for a good video that Russian put together,
mm-hmm.
and it sounds interesting, but you know, and if you look around the Earth, you think to yourself, holy shit, could there have been like 60-mile trees on Earth? And if there were, you know, who the hell cut them down, and why did they cut them down?
Right.
And why can't you find those trees anywhere but in Northern California, in the Sequoia National Forest? You can't find them anywhere else on Earth.
Right.
Well, and what were they used for?
Who knows?
I have my ideas on that also, and I'll definitely be talking about that tomorrow. But one thing I will say for sure is, you know, regarding the Grand Canyon, I have never bought ever, even when I wasn't a flat earther, I have never bought the idea that the Colorado River carved that canyon. I mean, to me, that's absolutely beyond absurd. And, you know, beyond that, there's a guy, Lee Bracker, and I know you know who Lee is.
Yeah, I know who Lee is, yeah.
And Lee did a really good video on the Grand Canyon, and what he did was he looked at the topographical map of it and how it matches a lot of the constellations in the sky. Now that, to me, suggests very strongly that it was intentionally carved out the way that it was, whether it was done by, you know, mining, quarrying equipment, or whether it was done as a monument by the ancients, I don't know. But I don't buy for 1 second that it was erosion as a result of the little bitty Colorado River. That's just ludicrous.
I was talking to John about this the other day. There is research data out there by these archaeologists and geologists that when they went to the Grand Canyon, they wanted to conduct tests to find out how old the Grand Canyon was, and they were under the assumption that water caused that erosion, and they found no evidence of water erosion.
Who went there?
A bunch of a team from National Geographic.
And who were they?
Oh, come on, John.
Are they scientists?
Come on. No.
They're not scientists. Thank you.
All right. So yeah, Bob's gonna have his show tomorrow. Robert Shortman and I are gonna talk on Thursday. John and I are gonna talk to Soho again sometime during the week. I don't know when exactly. And then Anthony Russo will continue hammering the hell out of anybody else that can't play nice and speak nice and ask, intelligent questions based on scientific information. Devon's got his channel. I know he and this guy's they're really focused on what's going on in Egypt and what happened there and how things are designed. A lot of it has to do with language as well. John, like I told you, they believe...
Right, the focus is geopolitics over there and how to regain power for indigenous around the world.
There you go.
Yep. Hey, Robert, if I can, I'd like to address one of the commenters in the chat, Alistair Kane, who is definitely a longtime viewer and stuff. And Alistair, I have to say that I understand your skepticism about the petrified forest idea. However, I will say that just like flat Earth, so much of this information could have been studied, like the test that you were talking about, Robert, that you're going to look for. And if there is any truth to this, then obviously we would know that it would have been suppressed in a massive way. So a lot of that data may be very difficult to find. But honestly, I mean, the idea is very interesting, and I think it's plausible. Whether or not it's true or not, I don't know, and I'm certainly not advocating that it is, but it certainly gives us a lot of food for thought, and I think that's absolutely worth exploring, and for people to try and dig up some additional data on. And that's
right. And it takes motivation to get someone out there with ground penetrating radar around the area in order to even examine that. Just like over there in Turtle Island, those heads that sit on the shore and looking out on the shore, right?
On Easter Island?
Say that again.
The Olmecs on Easter Island? Is that what you mean?
Yeah, Easter Island, excuse me.
Okay.
Easter Island. The heads that are looking out to sea, they've just recently found that those heads have complete bodies underneath the ground.
Yes.
So, there's not ground penetrating radar just floating around in the atmosphere all day, every day, looking at everything under the ground. So you have to have someone motivated to go to the area to do that.
Yes, absolutely. And if the finance is there to do it, nobody's going to do it.
Yeah, but see, here's the thing. They tried to do it down here in Colombia, in that national park I told you about, where they have those plateaus and the British government sent Prince Charles down here to have the Colombian military protect that area. So no one can go in there. And it's so dense that literally you couldn't get a vehicle in there. You have to fly everything in. And you got to get the permission of the Colombian government. And they've made it a national park so that no one can go in there and do exactly what you just described. It's the only area in Latin and South America where that exists.
Interesting.
It's the only area. And you ready for this? They didn't even know it existed 10 years ago. They didn't even know it existed. They said it wasn't even on any maps that the Colombian military and the government had. Some British guy stumbled across it. He went back to UK, got the British government involved. They told the Colombians about it, and then there's pictures of Prince Charles and the Ministry of Defense and the President of Colombia taking photos out of this place. And the best way to protect an area like that, so you don't have a shitload of researchers coming into the area, is what do? You make it a national park that's protected, and they're saying you can't come do this.
Exactly, Robert. I agree. And that's why nobody had ever heard of it before, because obviously if it's being suppressed, people aren't going to hear about it in the mainstream except for very, very obscure references. And then those are usually, propagandaed to death. That's, oh, this is just nonsense and crazy. And usually when you see patterns like that, it absolutely warrants looking into further, because those are the surefire signs that there is an intentional cover-up of this type of information.
Yeah, you're absolutely right on that one. All right, guys, listen, again, thank you. You guys know what my motto is. It's not what you know, it's what you can prove. I know that came from one of the most ruthless movies anybody ever saw, Training Day. But it's the truth, man. It's not what you know, it's what you can prove. Setting the truth free from a lifetime of bondage. We'll see you guys soon. And you guys got a whole host of channels you can go to find out some really good information. I know a lot of you hang out in the other 24/7 channels where they're just, I don't know what they're talking about, but I know John went in there one day to try to talk to them about the scientific method, and they got pissed off with him. They muted him, kicked him out. And then we got other guys. We got other guys out there we want to debate with and not, be hostile with them. We don't want to be hostile with them. We don't want to be confrontational. It's going to get confrontational, but not in a manner where you start calling people all kinds of names and shit, and
Hey, those chat rooms, they're train wrecks, man.
Yeah, I mean, it's just, it's not about us teaching anything. It's about us learning things and people learning things from us, and we're learning things from them. But when you want to totally reject everything that's being put out there, but you don't come back with us with any evidence or any information or any idea that makes sense that you can prove, then yeah, everything you're going to say is get dispensed with. We got people out there just disagreeing with us because they can disagree, but they can't tell us why they're disagreeing. And they're going to be who they are. We're going to be who we are, and I'm staying on point. I'm not going to be taking my show to the circus. I'm sorry, it's not going to happen that way. It'll happen with someone else, but it ain't going to happen with me. So again, guys, we really appreciate it. I do appreciate it. And I want to put this out there to people. Subscribers don't mean jack shit to me. You can subscribe. I'm grateful. I'm very appreciative. It's the views. If I put out a piece of information you find interesting and you want it to go a little bit further, that's more important to me, because I have 3 times as many people viewing my videos and what I have to say and sending me emails, and they don't subscribe at all. I actually have 3 times many viewers who are not subscribers than I have subscribers. Those numbers mean nothing to me. It's the quality and the amount of information I'm putting out. Because if I only have 5 subscribers, but those 5 people tell another 5, and they tell another 5, and tell another 5, and another 5, but no, I don't get, the subscriber count doesn't get any higher, it doesn't make a difference if I make 5 cents or $50. It's the information. You're getting it for free. I'm doing the homework for you. And if I need to do more homework, tell me which direction to look into, and we'll discuss it. That's where I'm at with this. And anyone else listening who may not comment, they just want to listen, if you want to debate something because you have some other information so we can correct ourselves, I am very open and humble to correct myself based on some information I might have misinterpreted, I might have misstated or misquoted. I will put out a video and correct it. I got no problem with that. I ain't going to let that shit stay up and let people believe that, because if I make a mistake, it needs to be corrected. There are people out there who don't want to take down some of their videos because, it might have got 10,000, 20,000, 30,000 views. That's money. I got no problem with that. But for me, if the video, I'll take down the video and put up a new one and say, hey, listen, I stand corrected. I made a mistake. Forgive me. All right?
Yep, I feel the same way, Robert.
Now, what you know is what you can prove. And that's what we're working towards, proving everything that we're claiming going against the status quo. I do not believe we have the technological capability to see anything from the surface of the earth millions of miles away, let alone light years away. Everything is closer. Everything. And the earth, I showed you in a virtual experiment, our atmospheric layers, I hope I proved that. I hoped I proved that. Our atmospheric layers may be acting as telescopic lenses to only see things thousands of miles away because we don't have the advanced man-made manufactured technological capability to see anything millions of miles away. We only have the capability to see things thousands of miles away. And then there's a limit to that.
Right. That's like saying that light never runs out of energy and just keeps traveling until it reaches your eye.
Yeah, that's absurd. I mean, 8 minutes for the sun's light to get to us? Really?
Yeah.
93 million miles, it's 8 minutes? Okay, build me a vehicle that can do the same thing.
Exactly, Robert. And that's been one of my biggest problems, not only with the starlights, being thousands of light years away, but also with the communications required to fire a signal back from Jupiter or, millions of miles away. The light and RF radiation both obey the inverse square law. And when you actually start looking at it and doing the calculations and try to figure out how much transmit power would be required at the source to make a transmission a billion miles away or 100 million miles away, it's absolutely ludicrous. Even a million miles away, you're starting to get into the gigawatts and terawatts, and these little puny solar arrays that are on these satellites supposedly could never generate that much power. So the whole idea is just nonsense, and I've challenged other RF engineers out there to prove me wrong on that, but I guarantee you it can't be done because RF and light both follow the inverse square law, and there is a finite distance to them regardless of the power. I mean, granted, the more power, the longer range you're going to get, but I'm sorry, these little satellites simply are not capable of producing that kind of power. Can't be done.
No, I don't care what size they are. When you tell me you launch something in the sky the size of a school bus, I'm like, really? Really? And it can only see how far?
Right.
Man, if I had the capability to build a telescope the size of a school bus, I'll be doing exactly what DeVos said. I'll be looking back 100 years into the past or 100 years into the future.
Yeah.
And what are those melting points on those satellites that they're made of?
Yeah, right. Exactly. Exactly. Exactly.
There's no convection in space? Thank you.
All right, people. Again, thank you very much. You guys be good to each other. Have fun out there. Be safe. Don't be saying anything crazy out there that can be used against you in a court of law. Because we know that YouTube's recording all this shit on supercomputers. But you guys got several shows tomorrow's gonna go on. I'm gonna probably be watching Bob and the thing to see where they go with the large tree theory. And we'll see you guys during the week. Take care of yourselves. Peace out.